Hello friends, you're welcome to the Pioneer STEM Show and thank you so much for not missing out on today's episode. Remember, we showcase activities, personalities around science, technology, engineering, and mathematics. My name is Choma Umolaye.
And I am David Adeosun.
Absolutely. You might want to tell them what we'll be learning today.
Okay, so today we'll be learning about 3D modeling and 3D printing.
Absolutely. And no other person to do justice to that is Felix Amaefule. He is a professional and expert in the field who has been in this field for like 14 years. Here, a funny sound is the sound of a 3D printer. He's going to be coming very soon to tell us all about 3D modeling, designs, and of course, we'll be printing out something live here on set.
If you want to be on the show, do well to reach out to us on our social media handles as seen on the screen.
All right, so as we do on the show, I like to ask you, what in this week has fascinated you or turned you down?
Yes, so in tech, what fascinated me this week is a super successful software company creating a product and it failing, which just shows that just because you're a successful company does not mean you cannot have a failed endeavor. So they invested billions of dollars in R&D, in even advertisements, and yet people
Why did it fail? Because even the small 4,000 naira phones, they're still successful. So yes. Why did it fail?
I believe the crazy price of the product is probably one of the reasons. So when you pay for
high-end.
So when you pay for products, you don't just pay for the products or the innovation itself. You also pay for the marketing, the advertisement, the brand. So I believe the price was one of the reasons why it failed.
The price? Maybe the price wasn't matching the value.
Yes.
For me, it's a turn down. A big tech company is closing down a part of its operation here in Nigeria. I don't know why. Rumors have it that over 200 jobs will be lost. I really hope it's not true, but that brings me back to the question. It's a great company and they're doing well. So why would they want all those workers to go? I mean, tech, data, software, everything is a new wave now. Why do you think these tech companies, they close down? I know we've heard of other bigger global companies, shutting down, or not even shutting down, reducing their workforce. Why do you think that is happening, David?
I believe running business in Africa is much harder than running business anywhere in the world. That probably explains why we have so many few successful companies, especially in the area of tech. So that could be a reason, but I'm sure there are more internal reasons.
It could also be maybe they found a way to automate something, or maybe that product, possibly they're not into it again. I mean, some part of it.
That could be a possibility.
Well, jobs might be lost. Like I said, it's a rumor. And so the fun part and learning part begins when we bring up on stage our guest, Felix Amaefule. Stay with us and learn. Welcome back to the Pioneer STEM Show. Our guest is already with us. Like we introduced him, his name is Felix Amaefule, a phenomenal, seasoned professional in the field of 3D designs and printing. Thank you so much. Let me give you a handshake. And I mean, coming within a short time notice. Thank you so much.
No.
All right. So you are a graduate of mechanical engineering from FUTU.
Yes.
Right. And then you're into 3D printing. What's the connect?
It's a seamless connection because we can't talk about 3D printing without mechanical, which is a very significant part of 3D printing. So there are different other fields from like embedded system, electronics, and all.
Yeah.
Mechanical is at the center of
Perfect. Thank you for answering that so well. Okay, so tell us more about yourself and what you do in this space.
Okay, so I'll see myself more as a product development person, person that's focused on products.
Okay.
May not be that person that is, a nerd, because probably I started with that in identity, but I wanted to disassociate myself from right. So
you were too nerdy.
Yeah,
You
so
felt that the society would leave you, and so you wanted the fun part of the society, right?
Sure,
okay.
Sure.
What is product development and 3D printing? How is it related together, and how do you do it in your everyday life?
Okay, so let me first try to define the concept of products.
Okay, perfect.
You know, and most of the times we misunderstand what really product, because for whatever we have around us here is product.
Everything here.
Everything here is product. So there's kind of that imagination comes out of it, and then the process, the design, and all that comes. So it's important for us to understand that, you know, moving from when we talk about product development, if we're talking about products, then developing the products and how it could interact with human being. But again, if you're interacting with a human being, then it means that we have to think about who uses that product, which is the users. And that's why, you know, I was really felt bad when, you know, we talk about the STEM, like the issues that have about people shutting down and companies failing. Most times it's not about the technologies, it's about not considering the users. Because how many times have you, when you bought the shirt, right? Yeah. You're wearing now. Yeah. Did you think about the suffering, the nights over time of the person that went through before, for them to get it out? No. You went there, you loved it, and then you looked at the quality for your money, is getting the value for your money, and you bought it. So, for us really in STEM, we need to think from that aspect for us to start creating value. You know, we love the Eureka moment. Oh, we want it. We just had that thing, and we are excited. Idea. But again, you shouldn't die. You shouldn't die there. We should think about how that really solves people's problem and build that product around, adapt to people's problem today and even for tomorrow. As so it's a constant thing, innovation that comes into it. Okay, so if I get you from idea to then designing it, and then prototyping it, and then commercializing it. Yeah, manufacturing and other issues. Manufacturing it, and then of course commercializing it. And that also comes to product delivery. You know, thinking about even the marketing part of it, right? How to deliver that product and it gets to the hands of the users, because the intention from when it's in the brain is for it to get in the hands of the people who will use it, and it makes impact in them. Absolutely. Okay, so tell us now about the 3D part, especially, you know, softwares you use for 3D designs, you know, modeling and prototyping, all those jargons. Right, so when it comes to the 3D world, you know, whatever we're doing now is just a mimicking of the nature where we exist. Okay. Because 3D exists in a space, and where we are standing is a space. It's not a 2D, so it's a replication of what we know already, which is like 3D. But now in a virtual space where we can really put the geometries and the mathematics and the whole numbers into calculations and all that. I also believe that the world is made of numbers. That's it. So everything comes 100%. Together. That really comes to that thinking and all that. But again, when you talk about the 3D design, there are softwares that really get to help you. And those softwares are tools, not really like they are the center point. Sometimes we keep referencing on those softwares. But again, for me, the software is as good as the user. So if you have a dumb user, the software is dumb. If you have a very brilliant user, the software is brilliant. Right? So those are tools that automate the processes. Instead of staying in the engineering drawing, you know, quite in the early 60s, early 70s, when you have to have series of people staying all night with lamps and how to draw. Absolutely. You know, you could really crash down their work of 1 month in 2-3 days. That's really where the innovation is coming from. That's it. So you are the CEO, should I say, of Generative CAD Services. So you've been training people, I believe, for a very long time. So what have they done? What are your success stories, even while you're still training? So what have been your success stories? Okay, so one of the biggest success stories for me is me, myself. Right? Oh, of course. You trained yourself. How did you even train yourself? We'll come to that. Yes. So, but tell us about those that you've trained. It has been amazing. Okay. It's really pretty much amazing, because let me just have a flashback. Okay. 2 days ago, we had a partnership collaboration with NIMEC National. That is Nigerian Institute of Mechanical Engineering. So we're partnering with them on national level to deliver human capacity development. Yay! High five! for the entire professionals. You waited till you came to to give me this news. Right. Well, so congratulations. It was, you know, so that also really tells us that, you know, what we have been doing, like, there's no notice on the national level. for such partnership.
Absolutely.
And good number of the things we looked at is, from the part of the hardware, we produce quite a lot of talents who probably are not in Nigeria, and probably some of them, good number of them are also in Nigeria, but working with US firm. We have been able to produce talent that work, as fellowships in engineering for change fellowships to Autodesk foundations and the rest of them, and even some other both local and international, people. And one core thing about is our training is not just based to 3D CAD. Rather, we think about people on the mindset, because design is a mindset. So what you need, the tools you need, the kind of standards you need to do, the manufacturability, because not everything you can design can be manufactured. And even not everything that can be manufactured by one technology can be manufactured set exactly by the next technology. So understanding the workflows and all that has to do, and also understanding the use cases. If I have to use a product, in what case is it going to be used inside the deep sea, or in the land, or in the house, and all that? So different considerations have to come in. So we need to so we teach people to understand context so that they can think for themselves on a particular reality they are working on, and not just use one tool and want to solve every problem in their environment.
Absolutely. So could you give us case studies, of or evolution, would I say, and case studies of 3D printing in different sectors, just to drive home the importance of 3D printing?
It has been that, I think for me, 3D printing is one of the technologies that will take Africa to the next level.
Ooh,
because, yes, it is. When we're talking about manufacturing and production, because it actually empowers the small and medium scale businesses to be able to, people who cannot do 10 million or 20 million like Coca-Cola, but they can do 50, 100. Right? So, and in Nigeria, even our economy, about 50% or more is powered by the SMEs.
Sorry, how cost effective will it be for the SME, considering the price of the 3D printer and, of course, the whole assets or resources you need for it? So, do you think it will be cost effective maybe now or in the long run?
Now, it is the most cost effective for them.
Oh, wow.
Right. Now, in the small numbers, it is even the most cost effective. And if you add a lot of creativity, then it can even be more for you. Why? Because you don't even need to own a printer for you to, because we have 3D printing service, which we even offer for a lot of people.
So you can design yours and send to
you don't even need to design, just the concept. You can come to us, we do the design, print, and ship to you. Like, you can bring your ideas without even being an engineer.
I've been wanting to ask someone like you in this field. I haven't seen, so you are here to confirm if it's true or not, about how 3D printing is helping print different medical, even our organs, like the lungs, let's say the lungs.
Spinal cord.
Spinal cords. And
implants,
and it's being implanted. Oh, wow.
So yeah, it is true that 3D printing really is revolutionizing medical from biomedical engineering. And I will say that the medical sector, 3D printing and the automotive and the aerospace is one of the biggest.
Aerospace.
Yes, aerospace.
What is it about aerospace?
So I'll get there, right? It's one of the biggest, people who are really adopting, like they're really looking for a way to adopt. One of the aspects of the aerospace, before I flash back to medical, is how many Boeing planes do you produce in a year?
Ooh, and
right?
So
you're probably going to just want to, and then through the traditional process of manufacturing, you are going through a process that caters for mass for one, so you're spending money so much just produce for pieces. But with 3D printing, it allows you that level of flexibility and also offers you that small quantity. And secondly, also,
is it to produce a prototype or the real?
Yes, the real thing.
What kind
Most
of
the planes you have,
so
you have
massive
new planes you
machines.
have today. Yes,
there are massive 3D machines that produce big planes like that.
There are massive machines that produce houses.
Oh, wow.
So
oh, wow.
so you're talking about but yes, even for houses, right? You have a one-story building that is built in Dubai for house, even in Germany.
Oh, wow.
So
awesome. And so you were going to go back to the medical before
yes. So, and then for the part of the medical, it has been really, really revolutionary because it has really aided what we call personalized healthcare.
Oh, wow.
Right. So let me speak from the aspect of orthotics. From the normal traditional way, you have sizes and scale. So it's mass produced. and you have to go to the hospital, the size you the ones that fits in.
Oh, yeah.
But today, I even work with a startup in Lagos that actually is doing a lot. They even have 3D printers, and we helped them get a few printers also recently.
Oh.
And what they are doing is to, they're focusing the biomedical and orthodox sector
Awesome.
of the orthodontics design, customize, and fix it into the store. And even 3D print foods that is flexible and all this. We see what is happening, and each of them is customized for each patient.
Yes,
and
patient.
Then, I know also that in the medical there is quite a lot of expense, even when it's mass produced.
Yeah.
So coming from this aspect of personalization and customization, you see a whole lot happening.
Awesome.
It's a whole lot.
Oh, wow. It's been an awesome learning time. I almost forgot myself on set. And so viewers at home, I hope you have learned something from today's show. When we return, we will have Mr. Felix demonstrate different parts of a 3D printer. Like we said, we have a 3D printer right here on set, and we're already printing something. We'll ask him all the questions. You do the listening and also do the engaging. We'll be right back after this short break. Don't you touch that dial.
Okay, can you please explain what is going on right now?
So what is going on right now is actually the printing, right?
Okay.
The printer is printing something, and this is what it's actually printing. We did this, quite earlier, and then it also comes in that it has to feed into a digital file, first, which come from the design. Softwares like maybe Fusion 3, Autodesk Fusion, or SolidWorks, or maybe Autodesk Inventor, or even Maya or 3ds Max, and quite Blender or whatever. But it depends on the kind of things you want to do, model and all that, depending on the kind of software you should use. So if you're doing something products, mechanical, and all that, you should use more of the Fusion, Autodesk Inventor, and SolidWorks. So now when you do the design, so you now convert to STFI.
Okay.
Now from the STFI, you take it to the software where you can slice. We call it slicing. So it's actually like preparing it and generating a G code out of it. So that's the point in time you choose the material you want to use. That's the point where you choose the printing speed. That's also the point where you choose the material configuration inside. Because the 3D printing is not fully solid. So you can actually choose at a particular infill of 10%, 80%, and all that, depending on the use case and also what you are working on.
Okay, from what you're saying, it sounds as if 3D modeling is more difficult than the printing itself. Is that what you're saying?
So it is the first step. If you don't have a design, 3D model design or 3D design, you can't print anything. Like you can't print something out of thin air. So yeah, it's the first journey. But I wouldn't say also this is just very easy. It could be easier for people. Okay, it could be easier for me in the years in the industry, but it might also not be easier for someone else. And that 3D design might be easier for them. But one core thing around it is it's not just the printing. Oh, if I get the STFI and slide it for you, maybe printing is a very basic thing, right? I can slot it in here and press one or two buttons, select the file, and but again, that is if everything is in good condition, right? But if I needed to change the filament, then you need to start understanding some other things. If I needed to do the slicing, then the regulation of the temperature, the bed, because this bed is heated, is not at 0 degrees or 25 degrees of room temperature. You could have to put it at 40 degrees. There are some materials you put at 70 degrees. Some you can even put at 100 degrees.
Okay, so that's 40 degrees written there.
So the bed
Okay.
is at 40 degrees, but the extruder, right, this is the extruder where that pulls out the filaments. So it's actually at 200 degrees. Okay. So but this extruder, there's a nozzle here. Probably going to see there's a nozzle there, down there, where the filament is coming out. So that is where the final heating is doing. And for safety reasons, you shouldn't touch there. So you can touch here, but not that nozzle because it's operating at 200 degrees Celsius. So that's crazy,
That's hotter than boiling water.
Right, so it's crazy. You wouldn't want to go there. But what it comes in is, it comes here, the filament. Okay. So it comes here, and then you feed it into the extruder, and then it comes in. So at every point in time, it draws it out and it deposits at a layer. The bed goes down a bit. That's the Z-axis we are talking about. So the extruder moves X and Y. You say it move this way, you say it move this way, so X and Y. But now the Z-axis is taken care of by the bed, by the platform. So at every layer of printing, the bed goes down. Then, but this one also takes that plane, that surface plane. Then the bed also keep going down, so until it prints finished printing. So that's the X, Y, Z. So the extruder takes the X, Y, and then the bed, which is where it's printed on, takes the Z as is.
As a Nigerian, I have to ask, what will happen if NEPA carry lights?
So that there's dynamics to these things. So we live in a country that we need to understand the dynamics and work around these things. And it's not just about the 3D printer, right? So first, what we do is we work with UPS. So you have to put it in the UPS. But there's also one of our printers, or about two of our printers, has a resume button. So even when the part takes light, fine, it doesn't matter. Even though we switch without the UPS, we just go power it on. It brings it up and to our screen and say resume. If you resume it, it still resumes from where it is. So you have a memory hibernation in your storage, but this does not have. So that's where when we're printing with this, either we use throughout solar or we have to use a UPS to back it up.
Okay, so for a basic print, how long does it take?
So the basic print is quite relative.
Yes.
It could take 30 minutes, it could take 10 minutes, it would take, we have done a print of 37 hours. Right,
wow.
So expect me is 37 hours. So it depends on what you're working on and the kind of engineering that goes into it, right? Because if it's something that is going to be used in the field and it's something I'm going to keep in the house, there are different design, work process. There are also different kind of materials that we use, and depending on the materials I'm using, determine the kind of printing speed and all that. So it's kind of a dynamic. So I can push something and print a button, right? And then maybe 10 minutes, 5 minutes is done. I also do something and then 50 hours is still printing, right? So
for this to be a product that reaches the masses, I'm thinking of an AI where you don't actually have to learn Fusion 360, SolidWorks, where just using prompts, you could actually get your design. You think that's something that's a possible reality? So
it's already in that, we're already in that dynamics. I think Autodesk just launched a research product that is still not for public use, so internally, right? So for some of the partners which we have. So you can even use an image and generate a 3D model.
Wow.
But, yes, and then even in some of the traditional products, you can also start integrating ChatGPT into it as an add-in, and then you prompt stuff and it comes to you. But the issue here we first to understand is we keep talking about the skills on the basis of the tools. No, the skill is about the knowledge of what comes in. Because if you understand how I need to produce this, in what situation and scenario and case studies and all that, that is what will inform the prompting. Right? Even in your normal ChatGPT, you put in and all that. If you have a domain knowledge, you better prompt it better than to give you a better result. Sometimes you even supply a significant data to it and it gives you some better result.
Prompt engineering.
Yes, prompt engineering, which I do a lot of times. So when you do that, you understand that the skill is not to be wished away. Right? Yes, the tools are to make our lives better, but it shouldn't make us lazy. Right? And we should adapt the skills and then probably maybe update our knowledge on the tools, which will keep evolving.
This has been very insightful. Thank you so much, sir.
Thank you so much.
Welcome back to the Pioneer STEM Show. And so if it's your first time seeing a 3D printer, please give us a thumbs up on all of our social media handles, brought to you by the Pioneer STEM Show. All right, so what was so outstanding for you today?
It's incredible how there's so much going on in the tech space in Nigeria.
Absolutely.
We have a company that turns people's ideas into products using 3D printing, which is fantastic. I've learned quite a few things about 3D printing and how the future of 3D printing is going to be accessible to people, especially with the rise in AI and generative text.
For me, one key takeout was, because I had this mindset that with 3D printing or using 3D printing for manufacturing, will it be cost effective for small and medium enterprises? But alas, the professional said it here himself that it's even more cost effective than any other method, and that he also sees 3D printing and 3D design growing so massively, in Africa and of course in Nigeria. So we're growing.
Yes.
That part where you said, what if NEPA takes light? You gave yourself out of NEPA, the time of NEPA. We Gen Zs, we say power outage.
It's right? NEPA, I'm still in Nigeria.
We Gen Zs, it's no longer NEPA. And so this is the time where we draw the curtain and bid you farewell. Thank you so much for sticking with us through thick and thin, rain and sunshine. See you same time next week. Bye for now.